Road to Olympiad.
Welcome to RTO. Consider the following problem. Prove that for every convex quadrilateral with area 1, the sum of the sides and the diagonals is at least 4 plus square root of 8. Convex quadrilateral is a quadrilateral where all the interior angles are less than 180 degrees. Experimenting with a square of side length 1, we can see that the minimum or the equality is achieved. But how are we going to show the statement generally? Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by considering any convex quadrilaterals ABCD. We can let the intersection of the diagonal AC and BD be O, and let the angle AOB be X degree. Based on the information we have, what we are going to prove is that AB plus BC plus CD plus DA plus AC plus BD is greater than or equal to 4 plus square root of 8. Notice that the area of the quadrilaterals can be written as the sum of the 4 triangles AOB, BOC, COD and DOA this way, which is equal to 1. And the equations can be simplified into this one. Notice that the angles AOB and DOC is clearly equal to X, but angle BOC and AOD are actually equal to 180 degree minus X. But sine of 180 minus X is simply sine of X. That's why we obtain the equations here. With this, we can factorize the sine of X and further factorize the expression we have in the bracket into AO plus CO times BO plus DO. Notice that the expression we have is simply less than or equal to half times AO plus CO times BO plus DO, since the angle is less than 180 degrees. Where AO plus CO here is simply equal to the diagonal AC, and BO plus DO is simply equal to the diagonal BD. Applying the AMGM inequality, the product AC times BD is less than or equal to the square of AC plus BD the whole thing over 2. Where we can factorize the denominator 2 to get 1 over 8 times AC plus BD the whole thing square. With the inequality 1 is less than or equal to 1 over 8 times AC plus BD the whole thing square, we have part of the inequality required. AC plus BD is greater than or equal to 8. Next, notice that the area of triangle ABC, BCD, CDA and DAB add up to be the twice of the area of the quadrilaterals, which is equal to 2. This is simply less than this one, since the angle again are all less than 180 degrees. Factorizing the half, we notice that the expressions can be further factorized into half times AB plus CD times BC plus DA. Similar to the first inequality, we can apply the AMGM inequality to get that the expression is less than or equal to half times AB plus CD plus BC plus DA the whole thing over 2 the whole thing square. Similar to the first inequality, we can factorize the denominator 2 to obtain 2 is less than or equal to 1 over 8 times AB plus BC plus CD plus DA the whole thing square. Rearranging the inequality gives us AB plus BC plus CD plus DA is greater than or equal to 16, which is equal to 4. And this gives us the other part of the required inequality. Adding the two inequality, use AB plus BC plus CD plus DA plus AC plus BD is greater than or equal to 4 plus square root of A, which finishes the proof. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.